Welcome to this video on SQL and data science. Here we'll explore how structured query language, or SQL, plays a crucial role in data analysis and machine learning. Get ready to discover how you can leverage SQL to extract, manipulate, and prepare data for your data science projects. So, what exactly is SQL? SQL stands for Structured Query Language. It is the standard language for interacting with databases. You can use it to manipulate and retrieve data. It is a vital tool for data preparation and data science. Here is a basic SQL query example. In this query, we're selecting the product name and price from the products table where the category is electronics and the price is greater than 500, ordering the results by price in descending order, and limiting the results to the top 10. Why is SQL so important for data science? Well, it offers several advantages. SQL is highly efficient, allowing you to process large datasets with optimized queries faster than traditional programming methods. It's excellent for data transformation, enabling you to clean, filter, aggregate, and prepare data for analysis or machine learning. SQL is a universal skill, commonly used across industries and platforms, making it essential in most data roles. It excels at handling structured data, allowing you to efficiently manage relational data with joins and complex operations. With SQL, you can ensure data quality by validating data with constraints and maintaining consistency and integrity. Finally, SQL seamlessly integrates with Python, R, and other data science tools, making it a versatile choice for any data scientist. Let's look at some key SQL components. The select statement retrieves data from one or more tables. The from statement specifies the tables you want to query. The where clause filters rows based on specified conditions. The group by clause aggregates data by specified columns. The having clause filters group data based on conditions. The join clause combines rows from multiple tables based on related columns. Here are a few code examples. The first example selects category, count, and average price from the products table, where the product is in stock. It groups the result by category and average price in descending order. Second query selects customer name and order date from the customers and orders tables using a join operation, where the total order amount is more than 1,000. Data cleaning is a crucial step in data science, and SQL provides powerful tools for this task. One common technique is handling null values. You can replace or filter missing data using functions like coalesce, nullif, and isNull. Another technique is string manipulation, where you can normalize text using functions like upper, lower, trim, and substring. Removing duplicates is also essential, and you can identify and remove duplicate records using distinct and group by. Lastly, type conversion is vital for ensuring data consistency, and you can convert between data types using functions like cast and convert. The code examples show some of these techniques. First example handles null values by replacing them with default values. Second example normalizes text data by trimming and converting strings to uppercase. The third example removes duplicate records by selecting distinct combinations of city, state, and zip code from the customer addresses table. SQL is excellent for data aggregation and analysis. Here are some key functions. Count, sum, and AVG are used to count records and calculate sums and averages. MIN and max allow you to find the minimum and maximum values in a dataset. The group by clause organizes data into groups for analysis. The having clause allows you to filter grouped results based on specific conditions. Here are a couple of code examples. The first example performs basic aggregation by counting products, averaging prices, and summing units sold, grouped by category. The second example shows advanced filtering by grouping sales data by region and product type, filtering results where total sales are greater than 10,000, and ordering the results by total sales in descending order. SQL can also be used for advanced tasks in machine learning. Feature engineering involves creating derived features using mathematical functions, window functions, and case statements to enhance predictive models. Time series analysis involves leveraging lag functions, moving averages, and date functions to analyze temporal patterns in your data. Data splitting involves creating training and test splits with random sampling and stratified sampling techniques directly in SQL. Here are a couple of code examples. The first example engineers features using case statements to categorize customers by age and calculates relative spending based on average purchase amounts. The second example performs random sampling to split data into training and test sets, using a random value to select 80% of the data for training. SQL and Python can be integrated to perform data science tasks. SQLAlchemy, a Python SQL toolkit and object relational mapper, provides comprehensive SQL functionality within Python. Pandas.read_SQL allows you to read SQL queries or database tables directly into a pandas data frame. SQL Magic Commands allows you to execute SQL directly in Jupyter Notebooks with the %SQL and %SQL Magic commands. Here is a code example. The code uses SQLAlchemy with pandas to connect to a PostgreSQL database, executes a SQL query to calculate total spending and purchase count for each customer, loads the results into a pandas data frame, and then selects specific columns as features for further analysis in Python. Optimizing SQL queries is crucial for improving performance, especially with large datasets. Use specific column selection. Instead of selecting all columns with select asterisk, specify only the columns you need. Utilize indexes to ensure queries leverage existing indexes, especially on large tables. Filter early. Apply where clauses before joins to reduce the volume of data processed. Avoid nested queries. Use joins, common table expressions, or temporary tables instead of heavily nested subqueries. Here are some examples. The first code example shows an inefficient query that uses implicit joins and selects all columns. The optimized query selects specific columns, uses explicit joins, and includes a where clause to filter data by order date. The second code example shows a nested subquery to find product names based on customer ID. The efficient query replaces the nested subqueries with joins to improve performance. SQL is used in various real-world applications. Customer segmentation involves grouping customers based on purchase patterns, demographics, and behavior for targeted marketing. Time series analysis involves analyzing temporal data for trends, seasonality, and forecasting business metrics. Predictive modeling involves preparing and transforming features for machine learning models to predict outcomes. A/B testing analysis involves comparing performance metrics between test groups to determine statistical significance. Here are a few code examples. First example shows how to create customer segments based on annual spending using a case statement. Second example calculates monthly sales growth rate using the LAG function to compare current month sales with previous month sales. Third example prepares features for predictive modeling by calculating average transaction amount, maximum transaction amount, and other statistics, then defines a target variable based on fraudulent activity. The fourth example analyzes A/B testing results by calculating conversion rates for different test groups. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.